Hi everyone, today we're going to do section 1.3, and section 1.3 actually has a lot of stuff crammed into it, so make sure you take some good notes. We'll practice again in class. So first we're going to be comparing real numbers, then we're also going to be doing square roots. So part one is square roots, and I've already talked to you about powers, and each one of these, you should write all of these down. 2, and we say to the power of 2 or 2 squared is 4. And we know that 3 squared means 3 times 3, which is 9. And 4 squared, 4 times 4 is 16. And 5 squared is 25. And 6 squared is 36. And the reason why I wrote these down for you is because the square root is asking you about one of two equal factors. And it's the opposite of squaring a number. So for example, if I asked you, what is the square root of 4, which is right here, you would tell me it's 2, because 2 times 2 equals 4. If I asked you what's the square root of 9, you would tell me 3, because 3 times 3 equals 9. If I asked you the square root of 16, you would tell me 4, because 4 times 4 is 16. The symbol that we use for square root is called the radical sign, which is right here. And the way that we make a radical sign, it kind of looks like a division sign, except it has a little check in front of it. So this is the square root symbol, or the radical sign, we call it. And we would say the square root of 25, like this. This is how it would be written. And I'm asking you what number times itself equals 25. And you would tell me that that is 5. Okay? For example, the square root of 81. What number times itself? That would be 9. 9 times 9 equals 81. So that's called square root. The perfect squares that you need to remember, ones that go in exactly evenly, are 1, because 1 times 1 is 1. 4 has a perfect square, which goes 2 times 2. Square root of 9 is 3, 16, 25. You need to know up to, I'm going to add 2 more to this. 121, which would be 11. 144, which would be 12. So I expect that you know up to at least 12 in your head. You should kind of have those memorized already. The key idea, actually I'm going to skip that because that's later on in the year. All right, part 2, estimating square roots. So not every number is going to go in perfectly. So when I ask you what's the square root, for example, of 15, which is number 1 down here, there is no number that's exactly that number times itself will give me 15. So we're going to estimate it. So what you're going to do, if you copy down the steps over here, right here, the first step you're going to do is you're going to find the 2 closest perfect squares. So, well, 15, I know, would be in between 9, which is a perfect square, and 16. So you have to think of the perfect squares that we just had. And the perfect squares, I'll list them again for you real quick, are 1, then 4, then 9, then 16, 25, 36, 49, that's 7, 8 would be 64, 9 is 81, and so on. And these keep going. So you're going to find between what 2 perfect squares? 15 lands right in between 9 and 16. And what you want to do to figure out the one that's closest to it, well, 15 is right next to 16. So we're going to say that this is approximately 4, because the square root of 16, I know, equals to 4. So this is really close to 4. It's going to be a little bit less than 4, so it's going to be 3.9 something about. But you just have to tell me which number it's closest to. Square root of 52. Square root of 52, well, that falls in between here and here, 49 and 64. So it's in between 49 and 64. And 52, that number is actually closer to 49, and we know that the square root of 49 is 7, so this is approximately 7. Okay, so we'll practice some more of those. That's some new topic stuff. Next, part 3, we're going to be classifying numbers. Now, this should kind of be a review. We're going to go over it. Irrational numbers are numbers that are not repeating or terminating, which means we can't put the bar over them, but they're going to go on forever. Numbers like that, here are some examples. The first one, you can't put a bar over, it's going on forever. If you did the second one, square root of 2, if you typed that in your calculator, which I'll show you how to do in class, you're going to get about 1.4142, and it keeps going. There's no repeating whatsoever. So again, that's irrational. Pi, the number pi never repeats, and it goes on forever. That's irrational. Real numbers are the set of rational and irrational numbers. And what I'd like you to do is draw this picture. The first numbers that you learned about are the natural numbers. They are 1, 2, actually I'm not going to put commas. 1, 2, 3, 4. They keep going on forever. So they're almost like the whole numbers. They have no pieces to them. They have no negatives. They start with 1 and they just keep going up. The whole numbers, which are just outside the natural numbers, have all the natural numbers inside them. That's why it's sitting inside the whole circle. But it also has the number 0. So whole numbers have 0, 1, 2, 3, 4. They also don't have pieces. It also doesn't have negatives. Integers, the next set, is when we start adding in our negatives, like -1, -2, -3, -4, -81. Again, still no pieces, but now we have the negatives, plus we have all the whole numbers and the natural numbers. Rational numbers are fractions or decimals. They may repeat, like 2/3 is 0.6 repeating, or 0.31 repeating. Irrational are the ones that go on forever, but they don't repeat, so you cannot put a bar. Okay, then we're going to practice some classifying. 17, you want to first start with natural numbers. Is that a natural number? Yeah, it doesn't have any pieces to it. It's not negative. So this one, 17, is a natural number. If you can tell me it's natural, it's going to be everything on the left side over here. It's going to be natural, whole, integers, and rational. Okay, so natural, whole, integers, and rational. This one, -72 divided by 6, is just another way to say -12, and -12 is an integer. If it's an integer, you work your way out, then it's also rational. The last one, the square root of 225, if I simplify that, I get 15. And 15 is a natural number. It's also a whole number, so you work your way out. If it's natural, it's going to be all of them on that left side. Integer and rational. And for now, I'm going to stop there. There are actually 2 more parts, but we will cover those in class. All right, have a good one.